Okay, my friends, this is just research. I'm keeping an eye on what they are doing in the medical arena and specifically on the microbiome. Now listen to this. This has to do with these weight loss drugs, and they're in such high demand they can't keep up with it. So listen to what they have to say. And this was on a report just today. They just can't keep up with the demand, and they're very expensive. Here goes.
Access to this Mounjaro manufacturing plant in Durham, North Carolina, where the company is ramping up supply. In this room, plant manager Dan Von Dilligan shows us how it takes only milliseconds to fill the drug into syringes.
How many can this do in an hour?
This is a high-speed filling machine, so on an annual basis, this will fill millions of syringes.
They're running this factory 24/7, tracking every step of the operation along the way.
You're able to see, again, every batch as it flows through the facility.
Is it common for manufacturing sites to run 24/7?
It is. For us, the demand is very high, and we're doing everything that we can to stand up and supply.
Eli Lilly is pouring $4 billion into this plant and another one it's building just 2 hours southwest in an effort to double output by the end of the year.
It's a massive scale of what we're trying to do. I don't think we have never done this as a company, and I think probably nobody else in the industry has scaled this as fast as we are trying to scale.
Can you move any faster than you're already going?
We're moving as fast as we can, but we have to follow certain controls to make sure that the final product meets our safety and quality expectations.
In recent weeks, Lilly and one of its competitors, Novo Nordisk, have both filed lawsuits against med spas, clinics, and compounding pharmacies for allegedly selling unapproved, unsafe versions of their drugs. Both were also recently sued over claims that their drugs can make the stomach empty food too slowly, resulting in abdominal pain and severe vomiting. In response, they say they closely monitor the drugs for safety. Back on the Mounjaro line, Von Dilligan says the team knows the importance of bringing the shortage to an end.
It's truly a privilege to be able to make medicine that's life-changing for our patients.
As the demand for weight loss drugs shows no signs of slowing down. So all of that results in an auto-injector pen like this, and of course this is an injectable medicine. This one doesn't have a needle, but you press this button and that's how you inject it. But because it's injected, they have to be so careful about how they manufacture it. That plant makes millions of doses of these medicines, or will, per year. And we were talking about the demand for these. As so many people are using them, the side effects are coming into focus a lot too. And that new study you mentioned today looks at the risks of things like gastroparesis, which is stomach paralysis, bowel obstruction, pancreatitis, which is inflammation of the pancreas. Some of these are known side effects, but the severity of them has been starting to come into question a bit more. This study in JAMA found about a 1% or lower incidence of these more severe risks for these GLP-1 drugs. They actually looked at Ozempic and an older version of the drug that people were using just for weight loss, not for diabetes. But these are things that are being watched closely in this class.
Yeah, wildly popular. Some of people need this drug, some want it. In both
That's
cases,
an important distinction.
It's wildly popular. Meg, thank you so much. Terrific report.
Okay, my friends, so all I'm doing is research. I look to see what everybody's saying about everything. Whatever's being posted, let's check it out and see if it makes sense. Now, what they're talking about is Ozempic, which is I believe the drug they were talking about a minute ago. I'm not sure. But these weight loss drugs, well, why do you lose weight? Because I understand the biology now pretty well, so I should be able to comment on this. I've been researching for quite a number of years now. The membrane that supports your health and also emits the bacterial enzymes, because that's where this bacteria lives, is in your gut. Now, what are they having? They're getting side effects of nausea, vomiting, diarrhea, abdominal pain, constipation. And, I don't know how common that is. We want to look into this. That's, they're saying it happens. And some serious side effects include allergic reactions, changes in vision, and pancreatitis. Now, we're going to look into what everybody has to say on both sides, because the manufacturer is saying, these things are perfectly safe, I believe. Now, this, to me, represents the reason you would lose weight, because you're not digesting your food correctly. And if you don't have correctly formed poop every day, and you're a regular and you have all your bacteria living in your body that's supposed to be there, you're not going to have the enzymes. If you don't have the enzymes, you're going to not be healthy. All right, so I showed you the fluid-filled highway. Well, what goes out? What happens in that fluid-filled highway? These guys go scooting around in there, picking up trash and delivering enzymes and going out to break down food. And what do they do? These are a single cell. It looks huge, I know, but it's a tiny, 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 tiny single cell, just like red blood cell, that type of thing. And it has a little whipper out of here, what do you call it, a flagellum. Now, it's not all of them have those, but most of them do, and some of them have multiple ones. Now, here's what this single-celled creature, it's a bacteria, it's a creature. That single-celled creature is like programmed through its own DNA, all this curly pink stuff, to create this one package. It's just like it was a factory machine, and you just turn them out over and over and over. And this package is what they call a ribosome. Well, what does a ribosome do, and why does it create it? Ribosome is going to end up turning into an enzyme. And the bacteria is the only possible way in the universe that you could create that particular type of a ribosome. When I show you how intricate the core of this ribosome is when it opens up and turns into an enzyme, it'll freak you out. And if you don't have that enzyme, you're not going to get the chemistry you need to do the job you need, and therefore your stomach will give you all kinds of issues, and then you won't poop right. You have constipation, diarrhea, you know, all kinds of issues in gut pain and gases and odors, and that is because you're not digesting your food correctly. So you need this little bacteria, and there's literally tens or maybe even hundreds of thousands of species. Nobody knows how many there is now. If somebody does, I want them to tell me, because I don't think anybody does. There's a bunch of them that are very well known, and then there's a whole slew of them that might do little bitty things, that because there's got to be so much chemistry going on in your body, you can't even imagine how complicated the membranes are, and the different chemistry, the different pH factors, the different flexibilities, the different, you know, mating up against other things, how membranes work, how molecules are broken down, how invaders are kept at bay, and they have all their own defenses. So this has to be a really serious dance. So you need really good bacteria, and then you need really bad bacteria. And you say, well, what do I need a bad bacteria for? Because the bad bacteria actually go out and eat up your body. But they eat it up after it dies. They eat up all the residue. But it's, you know, these guys got to keep them in check. Say, okay, there's enough out there, you feed on that. You go past that, we're coming out and getting you. And it sort of balances out. You got to think of it that way. It's a little bit of a mental exercise to understand this, but the key takeaway is here. There's thousands and thousands and really trillions of these in your body right now, of these bacteria. And every bacteria, its job is to do one of two things or both. Consume waste by going out through your body and consuming them in that fluid-filled highway, and then dragging them down to the lymph nodes and dumping them off or whatever, and also producing enzymes, which are these ribosomes. Now, let's see how they turn into their enzyme package. All right, don't forget, that's the fluid-filled highway. That's the little bacteria that's going to be roaming around in here. When it squirts out that ribosome, here's what happens. Those little balls come out, ribosomes. The sheath that holds them dissolves. The enzyme pops out, and when it comes out of there, it's like it's a magnetic, literally a magnetic chain, and it just swirls and twists and does all that stuff, and boom, locks in, and it says, okay, that's me. And if this isn't exactly identical to this, every single time, it won't work. It has to be exactly this arrangement and having all these different magnetic moments. A magnetic moment is, as I will show you, where the electricity, well, magnetism is, but it turns into electricity because these do what is called click chemistry. When these do their job, all they do is bump up into other things. They go click, you're dead, click, you're dead, click, you're dead. And when it does, it can do hundreds and thousands of them at one time, and it doesn't even get used up. It's like an executioner. But this is enzymes and proteins. They're basically the same thing. All right, proteins are not quite as exotic as enzymes. And here's what an enzyme looks like. This is what an enzyme looks like. You see that? Remember I showed you this? It's basically the same thing. These are different energy levels and states and so forth of these coiled, tangled magnetic particles. It's exactly what it is. And where you see these little red dots and blue dots on the end, that's basically going to be the dipole moments. They're where they have those little tiny centers of positive and negative charge. Because every particle that's attached to another particle has it's a set of charges that's unique to that particular arrangement. And here's what you're seeing. Now, what happens to that? It floats around through your body. This goes right through your blood. They're tiny, 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 tiny. And they just go everywhere. And if they see something that matches that magnetic signature, they go click, and that thing dies. Or it's a carrot, and they have to break it down to make it into some phosphorus or something. They go click, and it becomes a phosphorus. I mean, almost instantaneously. Well, literally instantaneously. Faster than that. It's just amazing what an enzyme can do. And that's what an enzyme is. And it does it by click chemistry. And that's because the actual truth of the matter is, in atoms, there is just thousands and thousands and thousands of different states in between every single one of these. They call them isotopes with half-lives. And that's why when these things come up, they go, and that all happens so fast that it changes into something instantaneously because of the enzyme catalyst working inside the isotope half-lives. You could never make life work without the isotopes and all the half-lives. And they have never even considered that. They don't even consider it. I never heard of anybody consider it, basically. Not the way I'm talking about it. This is the only way you can break down your food and create the stuff. And this stuff is roaming around through that fluid-filled highway. If you kill the bacteria, you don't have that enzyme. Your case is closed for that particular piece of chemistry, whatever it is. Either it's a thing that attacks invaders, which is a bacteria, or that creates an enzyme, and that click chemistry kills the invader, or it breaks down something for you to digest. Now, we're talking about these weight loss drugs. If you're having all these symptoms, you're going to lose weight because you're not digesting correctly. Now, is that a good thing? I don't know. They make it sound like it's the best thing you can do for yourself, but again, I don't say do this or don't do that. But when I see these things flying off the shelves and realize these people, and they're all losing weight, I guess this is the biggest thing going on. Well, obviously they can't keep up with the demand, and they say, "Where'd you get it? Where'd you get it? I wish I could get it." And I guess it costs a ton of money. But people are just desperate for this weight loss. And I think they might possibly be setting themselves up for a future issue. That's what I'm trying to see. That's what I'm thinking about. I'm not, like I said, no recommendations one way or the other. Just looking for the truth. All right, this is from a company that makes chemistry to clear water and so forth. And they're talking about bacteria and enzymes, just like I was. Now, what is bacteria? Bacteria are living cells, single cells, which have the capability of consuming waste. They can eat it up, of all different types. All right, because you got all kind of waste in your body, all kinds of stuff floating through your bloodstream. It has to be cleaned up by these bacteria. They can reproduce, so once they're there, they're going to just keep living in there as long as you don't kill them. And they actually producing enzymes. Now, better said, the bacteria are the factories that produce the enzymes. Without the bacteria, there's no factory. You can't produce the enzyme. Never going to happen. When the right bacteria are present in the right quantities and in the right conditions, they produce enzymes much more economically than people can manufacture them. So they're saying bacteria is the key, and it's the key to your health. You don't want to keep taking all these different supplements every day. You want that healthy bacteria living inside of you. That's what I'm talking about. Okay, this is a new organ system that they discovered, which is this fluid-filled highway, this little white line here. Underneath is the immune cells that house the bacteria and enzymes. They squirt them right into this fluid-filled highway, and little flagellas drag them around real fast. All right, think this through. This is very simple to understand. I talked to you about the enzymes. If you don't have the bacteria, you don't have the enzymes. Case closed. Well, what does an enzyme do? It acts very fast. Some enzymes, like carbonic anhydrase, can catalyze. Catalyze means to change over 1 million reactions in 1 second, and by so doing, they can speed up a reaction to a rate that is billions of times faster than its normal rate. Enzymes are generally much better catalysts than inorganic substances. Enzymes are the product of bacteria, and they only work because there's so many different molecular states in between all these, which is all the isotopes with their half-lives, and there's hundreds of thousands of them. That's why life can do it, because it's billions of times a second. All right, this is key to life, is nucleophilic substitutions. All right, biological reactions, and they create these nucleophilic invasions and substitutions. And it's always on an enzyme as the bond breaking occurs, because it just goes in and breaks them up and converts them into other molecules. You have an entering group and a leaving group. That's nucleophilic substitution. Now, don't confuse biological nucleophilic substitution, biological, with just a standard, invasive high acids and high salt invasion that pushes something out. That's a little different. Biological substitution is nucleophilic substitution as well, but it's from these enzymes and catalysts. All right, these are from aggressive chemistry in some cases. There's a couple different styles, I believe. That's my claim. I don't know if it's right or not, but I believe you would consider those two different styles of invasion. Crazy as this sounds, this goes back 10 years ago. They're saying where doctors had previously isolated only a few hundred bacterial species from the body, the researchers now calculate that more than 10,000 microbial species occupy the human ecosystem. That's 10,000 separate species. Now, moreover, researchers calculate that they have identified between 81 and 99% of all microorganismal genera in healthy adults. So they think they know everything that's supposed to be growing inside of you. I would dispute that now. This is 10 years ago. It's like they're, oh boy, we're really doing great research. It's just all lost. It's just lost like it never happened now. It says we have defined the boundaries of normal microbial variations in humans, said the Dr. Anderson, director of the National Institute of Health Division of a Program. Planning and strategy, that we now have a very good idea of what is normal for a healthy Western population and are beginning to learn how changes in the microbiome correlate with physiology and disease. Well, I have my ideas about that. Now, they also reported this plethora of microbes contributed more genes responsible for human survival than humans contribute. Anyway, the human genome carries 22,000 protein-coding genes. Researchers estimate the human microbiome contains some 8 million unique protein-coding genes, or 360 times more bacterial genes than human genes. And now, if they are not healthy, you are not gonna get the enzymes. Simple as that. Now, if they can calculate out what's all in your body, every single different bacteria, and you can get a quick printout of that, this is what we were trying to set up. And I was like working with people in Northern Ireland, Marguerite O'Reilly specifically, who's doing a fabulous job there. And they're trying to get a database going of what is natural and healthy. Now, in the meantime of us working for the last 4 or 5 years on this, her son has come back from a very, very, very serious case of autism, nonverbal, all that. He was going to be locked away to being a productive member of society with some very minor intervention. Now, we also have some more stuff we'd like to know about, but it's going to require some testing, and all that stuff always requires money. They're talking about getting $22 million years and years ago to do this. I haven't seen anything come of this at all. Something on it talks about getting funded for $22 million. And, right now we're still trying to figure out what's in the human gut. All right, so it's good that they did this, but it just got lost. It just got lost. Because right now there's still, where is it? I just saw it here somewhere. Clostridium difficile was one of the major problems, and they found out you could manage that with fecal matter transplants. It was the best option available. And this is fecal matter. It's poop from healthy people. How could that be so expensive and so denied to be even looked into? And it has not been looked into well whatsoever. Every time I look at a study, it says, more research has to be done. We have to do this. We have to do that. No, never gets done. And that is the key to creating enzymes. If you don't have the bacteria, you're not going to have the enzymes. The bacteria pretty much shows up in your poop. And if you had a fecal swab, and you could tell right away what was in there. We've been looking at, I got some, this is for doctors to treat patients. And we may be trying to set up with somebody to get these kits available so that you can offer them to do this job. But anyway, that's a whole other issue. All right. This is about this Ozempic, or whatever causes you to have nausea, vomiting, diarrhea, abdominal pain, constipation, all this stuff. And they say that is some of the side effects. Now, is this caused by the bacteria? That's what I want to know. If we could take a bacterial test before they start taking this stuff, and then one after, and see what is it affecting? Is it affecting the bacteria? Because in my mind, nothing happens in your body, absolutely zero chemistry, until an enzyme is involved. Right? Otherwise, things don't break down. They'll go right through you. If the enzyme isn't there to break it down or to kill it, if the stuff comes in you, kills it, it will kill you. Now, children, I'm only bringing up children. They have nothing to do with Ozempics and all that business, obviously. But as a child is born, they come into whatever environment they are in, and they have to become immune to the things that are going to try to attack them. It's just as simple as that. And what they do is they get from their parents or from their mother feces when they're born. They should be swabbed with feces. It really is. That's going to help them to survive. The feces have all the bacteria in it. They will absorb those and start to build their own immune system. And of course, the vaginal bacteria and all the bacteria that they get swabbed with on the birth process is immune system stuff. It's not bad for them. And then there also is some talk about the placenta not being cut as quickly as they do. I don't know about that for sure. That's something to be investigated. But there's a lot of things that we always thought, oh, clean them up, don't let them get dirty, and don't let them this and that, when they're little bitty things, you know. You don't want them to get invaded by really noxious, invasive things, no. But natural immunity comes from natural interactions. All right, you don't want them getting swabbed with all kinds of nasty stuff and living in a swamp, no. But you want them to be exposed to the natural things that everybody's exposed to. All right, if they have the correct immune system going on, it'll start to grow. Until they're about 3 years old, they have virtually no immune system at all almost. It's just beginning to take on. Now, there is the MMR shot, and I think that's a little bit early to be giving it to these kids. Now, I don't know, I'm not going to get involved in that, but it's a live virus that if they have no immune system, they can be overwhelmed. And that's, I think, is when I've heard a lot of my people tell me that they, after they got that shot in that area, their kids changed. And I know that there's been some talk, a researcher at MIT mentioned that was an issue they wanted to look into. So this is just looking into things. Because things can cause things, and nobody says, oh, no, don't talk about that, don't talk about that. Well, if you don't talk about it, and it is possible, I mean, almost anything's possible. If you don't examine what you can find out, well, then you have no information to work on. I'm a material scientist. I look for what, and then I talk about what it is, because I have to find out from other people, do they have any experience with it? I can't just talk about it to myself. What's good that going to do? Okay, we are looking at all sources of issues, and including possible viruses that come in and invade the baby at like a year old, a year and a half old, which is when they're giving them this MMR, weakened live virus. So they're giving them a virus that's going to attack them. But it's weak. And your body should be able to fight it off and just get it out of there. No problem. That should not be a problem. However, if your bacteria is not correct, prior to getting that shot, you may not be able to fight it off, and it may cause symptoms. All right? That's my point. And they did say, there was a published paper, and they retracted it, about MMR vaccine and autism. And it said it's a developmental disability that can cause significant social, communication, behavioral challenges. Absolutely. And this report was published and subsequently retracted by the journal. But originally they said it causes possible autism. And then they retracted and they said, no. And it has a strong genetic component with genesis before 1 year of age. Well, they're giving them this MMR shot at 1 year of age, right in that area. So it's kind of hard to tell, but I have a lot of people tell me that things changed. They saw things change. Now, I don't know if that's right or not, but what I want, the only way you can tell, is to find out prior to getting the shot whether their bacteria changed in their body. If their bacteria changed, what changed? Which bacteria was killed? Then we can pump them up before they take the shot. That's okay. I have no problem with having them take the shot. I've been shot up every which way you can be shot up. However, my bacteria is good. I have never had an issue with that. If you have a little bit of a gut issue, you're in trouble because you're not having that enzyme to fight back. So what do we need to do? Get a bacteria sample before and one after, and find out what happens in an MMR shot. Does certain bacteria get damaged? And if we can see it over and over and over, it's getting damaged, maybe we just give them a little hit of it before they go in for their shot. Something like that. All right, so I started off here with this Ozempic being a blockbuster diet drug, and everybody's just thrilled about it. And they can't make it fast enough, and they're all saying, boy, I'm losing weight. Well, that could happen. The Oscars, The moment when Hollywood's most famous glamorous gather to accept awards, show off their couture. Everybody looks great, remarked tells Jimmy Kimmel, walking around the stage. And everybody's taking this Ozempic. And then they can't find it. They're trying to get it. It's the worst kept secret in Hollywood. They're all taking it, apparently, to try to lose weight. But this could have some other issues. I'd think about it a little bit. And again, what is their gut bacteria situation before and after? And I'm telling you another thing. If you had the right gut bacteria, you should be able to, that should make you lose weight right there. That should take care of everything, basically. You should not be able to, it should be able to make you feel comfortable with what you get in you, because you'll be able to use what you get in you because you have the enzymes that can break it down. And you'll also have the enzymes that can attack invaders. It's a chemistry. You need that click chemistry. That's what it's all about. I think I would first look into, I think they should really look into fecal matter transplants, which is just nothing but somebody else's bacteria that was in their gut. That's all it is. No big deal. And you need it from at least 5 different people that are all healthy, because they're still going to have little variations. That's why when they say they can figure out 99% of the human gut, I don't think that's probably correct. But if they took hundreds of different people and looked at every single bit of their profile, and they could pick up on every one of these little DNA signatures of the bacteria, because the bacteria have DNA too. They have the same, just like our DNA. And if you could pick up that DNA signature all along, you'd know what's in that guy's gut. And I'm pretty sure they have a machine now that can do that pretty quick. So you'd have to have enough people, and sooner or later you'd find enough of these DNA sequences. You call them anything you want, I don't care what you call them, but they're going to be different microbes. And if everybody has all of those, you're fine. And you may find something where if anybody has those, they're sick no matter what. Those you don't want. So obviously you need something to get those out of you. It's going to be a dance. But you've got to figure what is in your gut before you can play around with all these other things to control your sugar and control this and cause it. It causes specific cancers like a pancreas or something, because that specific organ is supposed to make a specific enzyme, and it has to have a specific chemistry within it. And once you lose the acidity or something happens to that, because the bacteria is not there to do its enzyme job, well, then you're in trouble. And a symptom of that is gastrointestinal issues.